Have you ever looked up at a rainbow and just stopped? I mean, they're gorgeous, right? But what if I told you that what we're actually seeing is just the tip of the iceberg? That every single rainbow is a hint, a clue to this huge invisible world that's all around us all the time. All right, so let's get into it. You've probably seen this in a science class, right? A beam of plain white light hits a prism, and boom, a rainbow of colors comes out the other side. It looks cool, for sure, but it's so much more than a neat trick. It's literally the key to seeing a world that's right in front of us, but completely hidden from our eyes. Okay, so if we're going to understand this whole invisible world thing, we've got to start with the one we can see. We need to break down what's really going on inside that little piece of glass and figure out why white light just doesn't stay white. And there's a name for this, of course. It's called dispersion. All it means is that white light splits up into all its different colors when it goes through something like a prism. It's not magic, it's just pure physics. And you see it everywhere. Not just in prisms, but in every rainbow, every shimmer on a soap bubble. Now that band of colors, that's what we call the spectrum. And I bet you remember the old mnemonic for this one, right? Vib-G-War, for violet, indigo, blue, green, yellow, orange, and red. A classic for a reason. So why do they split up like that? Well, it all comes down to their wavelength. See, each color is a wave of light, and they all have slightly different lengths. When they hit the prism, they actually slow down a bit, and they bend. But, and this is the key part, the shorter waves, like violet, bend way more than the longer waves, like red. And that's what fans them out into that beautiful spectrum. Okay, so that's the story we can see. But this is where things get, well, kind of mind-bending. Because the story doesn't end with red. Nope. In fact, that's where the real story is just getting started. So naturally, scientists started to wonder, if the spectrum has these two ends, red on one side, violet on the other, is there anything out there in the dark, just past what we can see? Is that really all there is to light? And it turns out the answer was a huge yes. Back in 1800, an astronomer named William Herschel was playing around with a thermometer. He put it just past the red part of the spectrum, and the temperature went up. He'd found invisible heat rays, what we now call infrared. And get this, just a year later, another scientist, J. Ritter, discovered there was another invisible energy on the other side, past the violet, that could cause chemical reactions. That was ultraviolet light. All of a sudden, the invisible world was starting to come into focus. And those two discoveries, they were just the beginning. They were the first proof that what our eyes see isn't the whole picture, not even close. It's just one tiny little piece of a much, much bigger puzzle. And here it is, the big reveal. This is the electromagnetic spectrum. I mean, just look at it. To really wrap your head around this, think of it like a giant cosmic piano. All the light we can see, every color in the rainbow, the whole Vib-G-War thing, is like one single key, right in the middle. And on either side of that one key, you have all this other stuff. Radio waves, microwaves, X-rays, gamma rays, all completely invisible to us. So let that sink in for a second. Everything you've ever seen, your entire visual experience of the universe, is based on this tiny, tiny sliver of reality. The vast, vast majority of the light flying around the cosmos is totally invisible to us. But just because we can't see them doesn't mean we can't use them. Oh, we've gotten really good at using them. Think about it. Radio waves for, well, the radio. Microwaves to heat up your lunch. Infrared is in your TV remote. UV light sterilizes medical tools. We use X-rays to see broken bones and gamma rays to fight cancer. Our entire modern world is built on our ability to harness this invisible spectrum. All right, so we've gone from a simple rainbow to the entire invisible universe. Let's bring it back down to Earth for a minute and use what we've learned to answer a question every kid asks. Why is the sky blue? The answer has to do with something called scattering. It sounds complex, but it's pretty simple. When sunlight hits the little molecules of air in our atmosphere, the molecules absorb that light and then spit it back out in every direction. They literally just scatter it. But here's the kicker. Not all light scatters the same way. The short wavelength light, the blues and the violets, gets scattered like crazy by the atmosphere. But the long wavelength light, like red and orange, pretty much just sails right on through. So what you end up with is all that blue light getting bounced around all over the place, filling up the sky until it hits our eyes. And this exact same idea explains red sunsets.
Think about it. When the sun is low on the horizon, its light has to travel through way more atmosphere to reach you. By the time it gets to your eyes, almost all of that blue light has been scattered away. So what's left? You guessed it, just the longer wavelengths, the reds, the oranges, the yellows, making it all the way to you.
It's pretty amazing when you think about it, isn't it? Our eyes evolved to see just the tiny little slice of reality we needed to survive here on Earth. But our minds? Our curiosity? Well, that's what gave us the tools, the science, to see everything else.
And that kind of leaves you with one last big thought, doesn't it? For nearly all of human history, we were completely blind to most of the universe. Now that we've started to see it, it really makes you wonder, what else is out there that we're not seeing yet?